Okay, so we're going to be starting our last unit of the semester, and it kind of picks up with our last unit 5, where we're going to be looking at different ways we can rewrite trig functions to simplify them as much as possible. We're going to start off today by learning a few new laws. So we still will have our Pythagorean identities, we still have our reciprocal identities, we still have our cofunctions, and we still have odd and even. What we're going to add to that list is our angle addition laws. And so the reason we have these laws is because it helps us figure out what to do when it's not necessarily a cofunction, but we have something like, actually it's supposed to be a 60, not a 90. When we have something like this, now granted here's two numbers, but what if they're alphas and betas? Oftentimes we think, oh, well, can't we just do this? And the answer is no. Okay, that does not work. Because when we simplify this, cosine of 90 is actually 0. Whereas here, if we plugged in cosine 30 and cosine 60, we don't get 0. So this is a does not work. So what we have is a set of formulas that help us deal with how to rewrite an addition when alphas and betas and thetas are there instead of numbers. So we have a total of 6 here. So here are the first two formulas. The first one is what do we do when we add two things in a sine function? And then we'll have what do we do when we subtract two things in a sine function. So the patterns that you'll notice is the same for both of these with just a sign difference, just like the sign difference here. So for the sine, it's going to be sine of A times the cosine of B plus the cosine of A times the sine of B. For sine of A minus B, it's the same pattern, sine A cosine B minus cosine A sine B. So when we look at, for example, something like this, we have sine of 15. Now 15 degrees is not an exact angle. So what we want to think of is how can we write it as a sum or difference of two exact angles. So what we want to think of is if I were to take two of my exact angles, such as 45 and 30, 15 is the same as 45 minus 30. So that means I can rewrite this as sine of 45 minus 30. So I've got two exact angles in my difference. Using our difference rule, I can write this as sine, so this is going to be my A, 45 will be my A, and 30 will be my B. Sine of 45 cosine of 30 minus, I wrote that back, cosine of 45 times sine of 30. So what it's allowed us to do is to put everything in terms of numbers on our unit circle. So by taking a non-exact value and writing it as a sum or difference of two exact values, we can write a sine-cosine statement that we can read values off our unit circle. So from here, we actually know what sine of 45 is. We know it's root 2 over 2. We know what cosine 30 is. It's root 3 over 2. Minus, we know what cosine 45 is, and we know what sine of 30 is. follow our order of operations. We'll multiply and get root 6 over 4. Over here we'll multiply and get root 2 over 4, which we can add together because they already have a common denominator. Root 6 minus root 2 all over 4, and that would be your exact value answer. So this is what we use these addition formulas and subtraction formulas to do, is to just rewrite numbers that aren't exact into ones that are exact that we can do this substitution for. So these two are the formulas for sine. We also have them for cosine. So cosine of A plus B and cosine of A minus B. The cosines are same idea but a slightly different pattern. So we have cosine of A times cosine of B minus sine of A sine of B. And then for the subtraction of two terms inside of a cosine, it's cosine of A cosine of B plus sine A sine B. So if we had something similar to that example above, but with cosine, we would have used one of these patterns to plug in our values. So if we looked at the same one, but with a cosine. So let's stick with 15. So cosine of 15 degrees. I know that it's 45 minus 30, so I can rewrite this as cosine of 45 minus 30. So that means using the pattern for subtraction, it's going to be cosine of 45 times cosine of 30 plus sine of 45 sine of 30. And then just like before, we can go ahead and plug in our exact values. So cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Plus sine of 45 is root 2 over 2. And sine of 30 is 1/2. Simplify, we get root 6 over 4 plus root 2 over 4, which when we combine gives us root 6 plus root 2 all over 4. So again, you can kind of see how it's the same basic idea, just using a different formula or a different property, if you want to call it that, for each trig function. So lastly, we have tangent. The tangent of A plus B and the tangent of A minus B. So the tangent of A plus B we can write as tangent A plus tangent B over 1 minus tangent A times tangent B. When we turn it into a subtraction in here, the pattern's the same, tangent A, but minus tangent B all over 1 plus tangent A tangent B. So these are the 6 formulas that we're going to be looking at in class tomorrow, where we are going to be given problems like sine of 15 or cosine of 15 or even tangent of 15, to where we're going to plug them in, find a sum or difference of two of our exact values, and then rewrite it using the formulas so we can find an exact value. So in class on Friday, we're going to go over about 4 more examples of how to do these angle addition laws before we start our assignment.